An arch is a curved structure that spans an opening. It could be a window, it could be a doorway, but that curved surface is supporting some sort of load above. Now we're going to be learning how to construct some types of arches, but no matter what shape an arch is, we can always talk about certain measurements on that arch. So if you look at these two arches, they do look different, but if you look at both of the pictures, you'll see that in both cases there are two columns that are supporting the arch up above. The distance between those two columns is called the span. The arch itself is sitting on top of the columns, and the base of the arch is defined by a horizontal line called the spring line. And the rise is the distance between that spring line and the bottom of the arch. Now, one of the inherent problems with an arch is caused by the physics of the arch. Since we have this curved shape sitting on top of columns, the force of the weight from the curved shape isn't being directed straight downward. It's actually being directed down and out. So that has a tendency to make those columns want to be forced outward, and that means we could actually have the structure collapse. So what I'd like to show you is a simulation so that you can see what happens as we try to make the columns grow taller and taller, and how the physics of the arch can actually cause this to be an unstable structure. Alright, so this is an example of a rounded arch, and what we're going to do is increase the number of blocks that are making up the columns. So if we go up to 2 blocks, you can see that we still have a fair amount of stability. If we go up to 3 blocks, now you can see how those two columns are being forced out. If we make a pointed arch instead of a round arch, we have a little more stability. So there's 2 blocks in our columns. There's 3 and it's still standing, but you can see it's starting to get pushed out, and in fact we go up to 4 and the whole structure collapses. Now there were some tricks developed to make these arches a little more stable, and one of those tricks was the buttress. So a buttress is nothing more than a thicker wall that's on either side of the columns, and that thicker wall helps to absorb that sideways force that's trying to force the columns out. And another version of the buttress, which you see down below, is the flying buttress. And that also was used to absorb that outward force, but it was a way of building that outer wall to support the columns that didn't quite require as much stone as a regular buttress did. So let's see what happens if we add some buttresses to those arches. Okay, so we're back to the rounded arch, and we only have 1 layer of blocks underneath the arch. We're going to go up to 2 layers, and you can see that it's already starting to bow out just a little bit. If we add buttresses to either side, that gives it a little more stability. And you remember before, the rounded arch collapsed after 3 layers of blocks. Now with 3 layers of blocks, it's still standing. We go up to 4 layers, you can start to see it bow out just a little bit, and it becomes unstable at 5 layers. Now you remember the pointed arch, which was a little more stable. So here's the pointed arch with 5 layers, and it can still stand. If we go up to 6 layers, though, you can see it starts to get a little wobbly. And 7 layers of blocks, oh, it is just so ready to fall. The 8th layer, it finally goes. So the buttresses are giving it more stability. Now we also could put those flying buttresses in. So in this case, we're back to the rounded arch. The flying buttress should give this a little more support. So we're up to 3 layers, 4 layers, 5 layers. and it collapses at 6. I don't think that was a lot more support, but remember the flying buttress could actually give the support but use less stone to do it. So it was really a matter of conservation of materials that made them use flying buttresses instead of just buttresses. So we're going to use compass and straight edge to make some geometric constructions of arches, and we're going to start with the semicircular arch. The semicircular arch is called semicircular because of the shape of the arch that's above that spring line. It's in the shape of a semicircle. So we're going to start with this line segment that's defining the span of our arch, and it also is going to be our spring line. So what we're going to have to do is construct a semicircle that has these two endpoints as a diameter of the semicircle. So the first thing we're going to have to do is find the center of that semicircle, and we'll have to do that by finding the bisector of this line segment, and that's a familiar construction to us. So we're going to spread the compass a little wider than half the distance between those endpoints. We'll make arcs above and below, and we know that if we connect those intersections, we will have the perpendicular bisector of that line segment. Now what I'm interested in is not the entire perpendicular bisector. So what I'm really interested in is just this point right here that's going to define the center of my circle. So I'm going to go ahead and just so you can see that this is the perpendicular bisector, I'm just going to draw this in kind of with a dotted line so you can see that that's really a familiar construction to us. Now this point right here is the center of our semicircle. So we're going to have to find the radius of that semicircle, which is this distance from that center to the end point. And if we use that radius to draw a semicircle that goes from the left end point, and sorry if you're having trouble seeing through my hands, I'm trying to make this not slip. There we go. To right there, and we have our semicircular arch. The columns that support that would be down here, but we're not drawing the columns, we're just drawing the arch. The next type of arch that we're going to construct is called the equilateral pointed arch. And that word equilateral is familiar to you. We've talked about equilateral triangles. Well, that's where this arch gets its name. You'll see an equilateral triangle that's formed by the spring line of the arch and the center of the top of the arch. So let's start with a line segment again that is going to represent the spring line of the arch. And what we need up above is to imagine an equilateral triangle. Now we know an equilateral triangle has three sides that are the same length. So we're going to use the compass to measure the span of the arch. That would be the distance from one endpoint to the other endpoint along this spring line. Now if we were making an equilateral triangle, what we would do is have the point of our compass here and make a single arc up above, and then we would make a single arc up above here. But in this case we're trying to make an arch. So instead of just those two little tiny intersecting arcs up there, what we're going to do is draw something that looks like the outside or the edge of our arch. So from that end point we make an arc, and from this end point we just need to go up until those intersect, and now you can see our equilateral arch. The columns once again would be down here. We're not concerned with constructing the columns, we're just constructing the arch up above. The next arch we're going to construct is called a Lancet Arch. Now what's important to know about a Lancet Arch is that the rise is always going to be equal to the span. So if you take a look at this picture, you'll notice that with the rise equal to the span, you can see an isosceles triangle inside the arch. So constructing that isosceles triangle is going to be an important part of this construction. Here's an example of a window that is constructed using a Lancet Arch. So let's see how to construct one. Now in this case, what we're starting with is our spring line, which I've extended a little bit here so that we can see the span of our arch right here. But our spring line actually could continue as far out as we wanted to from that span. Now what we need to do is construct a triangle, an isosceles triangle, that has this span that's exactly the same as the rise of the arch. So the first thing we're going to do is construct a perpendicular bisector so that we can find where that vertex of our equilateral or our isosceles triangle is going to be. So back to an old familiar construction, we need to construct the perpendicular bisector of this line segment that represents our span. So arc above, arc below. Where those two pairs of arcs intersect, we'll define our perpendicular bisector of the line segment. So I'm going to go ahead and draw that in. Now we know that the vertex of our isosceles triangle is going to be up here somewhere. And what we need is for this distance, this rise, to be the same as this distance, the span. So let's measure the span. It's this far. And we want this rise to be the same as the span. So that distance, the rise, is equal to this distance, the span. So this point right here is actually going to be on our arch. And you can see that equilateral triangle. In fact, let me just kind of draw it in here for you so that you can really see it. The equilateral triangle is not part of the arch, but it is part of the construction for the arch. All right. If I said equilateral, I apologize. It's not equilateral. It is isosceles. All right, so there's our isosceles triangle. Now the next thing we need to do is find the perpendicular bisector of each of these equal sides. So remember, each of them are just line segments, so it's that same construction. We need the perpendicular bisector of this segment, so we need to make our compass a little more than half the distance. Make arcs on either side. Now you may find it easier to turn your paper, when I'm going to need to extend a little bit, aren't I? You may find it easier to turn your paper so that that line segment is horizontal. It might make more sense to you. I'm going to leave mine the way it is, so I'm not turning it all in circles for you. So that is the perpendicular bisector of this side of the isosceles triangle. So let me draw that in. And I want to make sure that I draw it long enough so that it reaches down here to this spring line. Now I want to do the same thing with this line segment. I need to find its perpendicular bisector, so it's exactly the same construction. Arcs on either side. We're getting a lot of arcs in the picture, aren't we? So be careful that you don't mix them up. Arcs on either side. Ugh, have to make that one longer again. It's kind of hard to tell when it's not horizontal. Okay, there we go. And then where these intersect, that will be our perpendicular bisector of that side. So let's draw that and make sure it extends all the way down to the spring line. All right, so now it looks like we have a mess of a picture, doesn't it? But what we need to do is find the distance from these points of intersection and our spring line. So these perpendicular bisectors we just constructed intersect with the spring line. We need to find the distance from there to the top of the arch, which, if we've done this correctly, should also be that same distance right there. That's the end of that spring line. So we draw an arc there, and then come over here to this other intersection with that perpendicular bisector in the spring line, and it's slipping just a little bit. And there we go. So there's our arch here and here. So this distance, the span, is the same as this distance, which is the rise. The next arch we're going to construct is called the ogee arch, and it's also called the Venetian arch. So if you are ever in Venice, or if you've ever been in Venice, and you get a chance to look at the buildings in Venice, you'll see a lot of these ogee arches there, which is why they're also called Venetian arches. What you'll notice that is very distinguished about the ogee arch is these kind of S shapes that are formed in the arch. So we're going to see how to construct this type of arch. Now once again, we're starting with a line segment that is on our spring line, and its width, the distance from these endpoints, one endpoint to the other endpoint, is equal to the span of the arch. So the first thing we need to do is find the perpendicular bisector of this line segment. So this is sounding familiar, isn't it? We've done this on a lot of these arch constructions. So same thing we've done before. We need arcs above and below that have the same radius that go from those endpoints. If we connect those up, we'll have perpendicular bisector of that line segment that's on our spring line. All right, so the next thing we need to do is construct a semicircle that has this point of intersection as its center, and it has to have the distance from here to here as its radius. And that should look familiar because that's exactly what we did when we constructed a semicircular arch. So we're going to start with that distance, and we're going to draw lines or a semicircle around. And once again, I apologize if you have a hard time seeing. I think I'll just switch this way. Hard not to block the camera when I do this. Okay, so there we go. There's our semicircle. If we were constructing a semicircular arch, we'd be done at this point. Now, the next thing we need to do is think about what a rectangle would look like that has this as one of its sides. Another side would go through that intersection, and then it would have to, of course, be at right angles to this side, and it would have to be parallel. These two sides are parallel to this. Now that's not as difficult as it sounds. We just need to duplicate some measurements that we see here. So for example, this radius of this semicircle, we're going to come up here to this intersection and mark off that radius. And in fact, since that distance is right here, I'm going to mark that off here. This distance from that spring line to this intersection, which is really the top of my arch, I need to also be here and also be here. So what I've got at this point is some intersections, and I'm just going to kind of draw these in with dotted lines so it doesn't get all confusing. But let me just draw those in because I think you'll be able to see the rectangle that we just constructed. And remember, we know it's a rectangle because we started this whole thing off by constructing a perpendicular. So we actually have a right angle in the picture that we've been building from. All right, so we're almost there to finish our OG arch. We've actually got part of it here with these curves. What we need to do is remeasure that radius. So we need that back again. And now from these corners of that rectangle, we need to draw arcs until they intersect with that semicircle. So here and from right there, like this. Now if you're thinking, where is the arch? We've actually got it done, so let me just kind of draw this in for you a little bit. The arch is actually here, and there's that S curve. It's going down there, and then it's up here. Now if you're doing this construction, you probably don't want to be drawing over this. I'm just darkening that a little bit so that you can see it better. So you can see that S curve, that OG arch that we've just constructed. Now one last construction that we're going to do is not actually an arch, but it's used a lot as a decorative part of an arch, and it's something called the trefoil. So trefoil actually means three-leaved plant. So if you think of something like a three-leaved clover, that's what this shape will remind you of. And if you look at the larger picture, you'll see how that is used in a round window. It's actually 3 circles that are contained within one larger circle. And if you look at the picture on the right side, you'll see how a trefoil design is being used as the back of a chair. So let's see how to construct a trefoil. So we're starting with a circle, and what we want to do is inscribe these 3 circles that make up the trefoil inside of this circle. So the first thing we're going to do is find a radius of that circle. So I'm going to just draw it in like that. And what I need to know is what the midpoint of that radius is. So think about that radius as just being a line segment that we want to bisect, which we've done many, many times. So I'm going to put from the left end point, arcs on either side. Well, it's the top end point, isn't it? Not the left end point. From the bottom end point, arcs on either side. And we know that if we connect up those arcs, that we have the perpendicular bisector of that line segment. All right, now the really, really important thing about that is actually this distance right here. That distance from the end point to the midpoint. Because that distance is defining a radius that I'm going to be using 4 times to make 4 circles in here. The first circle is going to have the same center as the large circle. So we'll just draw that around. I'll try to do this without blocking the camera too much, but I'm going to apologize if I do. So we're just making a circle all the way around like that. All right, now the next thing we're going to do is going to remind you a little bit of the construction we did when we were constructing a regular hexagon. I have not changed the setting on the compass. That's really important. So what we need to do is construct some parts of circles that have as their radius this same distance. So here's what we're going to do. I'm going to put the point of the compass right here on this intersection. I could actually put it anywhere on this inside circle, but I'm going to choose to put it right there. And I'm going to make an arc that's going to just come down and touch that inside circle. And you notice it just touches the outside circle too. So I slipped just a little bit there. Let me see if I can correct myself. There we go. So there's one of our 3 leaves. Now the next leaf, we have to find the center of. So this is the part that's going to remind you a little bit of what we did when we were constructing regular hexagons. I'm going to take the point of the compass, I have not changed the setting, put it on this intersection, and I'm going to make an arc here. That arc defines the center of my next circle. So here we go. Well, it's not a circle, it's a part of a circle. So bring this around, it just touches the outside circle, and there it goes, it meets up with that intersection. And then I'll put the point of the compass right here on the inner circle and make another arc. And now I'll use that intersection as the center of the third circle. I'm a little off here, so something slipped. But it should meet up exactly with this. I must have slipped just a little bit. So now you can see the trefoil. We've got the 3 leaves that are inscribed inside this larger circle. Now those probably seem like some fairly complex constructions simply because they have a lot more steps than some of the constructions we've done before. But the things that we're doing within there are things that we have done before. Things like finding a perpendicular bisector of a line segment. So practice the constructions as usual. It's the only way you're going to get better at them, and it's the only way you're going to remember how to do them.